Okay, so we have here an open tank contains 5.8 meters of water covered with 3.2 meters of kerosene, which has gamma of 8 kilonewton per m cube. So we're given with gamma. Find the pressure at the interface and at the bottom of the tank. So here, of course, we know how mas bugat or mas dako og density is kerosene or water. So in this case, water will be at the bottom. So in this case, water. So this is water. Ang water daw kay ang iyahang 5.8 meters. So that's water, 5.8 meters. Water nang nasa ubo, sa taas is kerosene. And ang kerosene is 3.2 meters ang iyahang uh, iyahang depth. So here we'll have here kandana pangandana, that's 3.2 meters. And of course, we know properties. Here, this is the gamma of this one, gamma of kerosene. We put here K for example. Gamma of kerosene is known to be 8,000, meaning 8 kilonewton per m cube. Gamma of water, of course, we know. Do we know what gamma of water is? Gamma water. That's simply rho g. Rho is 8,000 kilogram per m cube times g, so that will be 9810. So that's rho g, 9810. Now, we just want to calculate for the pressure at the interface. Meaning interface, kani, point A, between the layer between, of course we know that they will not mix. Water and kerosene won't mix. Hydrocarbons mo ng kerosene, or it is non-polar. Water is polar, so they don't combine. Now, PA therefore is simply, when we solve for PA, that is simply, well, the pressure at the surface, the free surface, if it's exposed to the atmosphere. Okay, so pressure diani kaning free. You know, as we go deeper, magka-increase ang pressure by rho gh, or rho g simply gamma h. Now, pila man na siya nga pressure diani? Well, if it's exposed to the open tank man, meaning zero ang imuhang pressure at the top, the free surface, then you go deeper, you increase by rho gh or gamma h. Rho g is gamma, so therefore gamma h. So may increase lang na siya value, so equal than to PA. Tama? Or we don't write it as this. So ano lang i-delete no? Pabaliktad ta. We write it as, well, pressure at the free surface, that's 0, plus as we go deeper, it increases by rho gh or gamma h. So gamma kerosene times depth of kerosene. In that case, what is depth of kerosene? So we just put here h of the kerosene equal to PA, right? And of course, PA could be solved because we're given with everything. Gamma is given to be 8,000, and here H is given to be 3.2, which means PA will only be dependent on the fluid above it, not on the fluid below point A. Ingana man ang pressure, only be dependent on fluid above it. If there's fluid above it, then it will cause an increase in pressure. If there's none, then bahala pag unsa nasa ilalim. So that's 8,000 times 3.2 equal to PA. And therefore, PA will be equal to, what is that? 8,000 times 3. 25,600. Okay? So that's 25,600 Pascal. Now, also we're looking for, find the pressure at the bottom of the tank. So what could be the pressure that will be read by the gauge here at the bottom of the tank? So how do we do that? Well, we could really start from the top. We know that the bottom is daghan kayong fluid above niya na ay kerosene na po yung water. So it's really additive. Pwede nimo siya, dili pwede isahon nimo siya treat no, because they are not really mixed. In this case, isa-isahon nimo, or you could just think of, well, PA, as you go deeper, this is point A here. As you go deeper, it will increase by gamma or rho gh or gamma h, then you will get PB. So I think it will be simpler. We start with PA, which we know 25,600. meaning dito ka nag-start nga point. We go deeper, it will increase by gamma. But of course, gamma here, the fluid here is water. So that will be gamma of water, which is in our case 9810 times the depth. How much do you go deeper? That's 5.8. Okay? And that will then be equal to the pressure at point B. That's PB. So simply, therefore, PB is simply equal to ilang PB? That's 82,000. 82,498. The unit, of course, is Pascal. Of course, it will be easy to round this up to 25.6 kilopascal. Then you box that because that's being monanggi pangayo. Okay, you box that as your answer, and here also you box this as your answer. Or you could say equal to 82.5 kilopascal. Anyway, that's engineering. Engineering, it's acceptable.